Welcome to this training series on Power BI. In this training series, I'll be presenting 5 modules. Module 1, the Microsoft Power BI Overview. Module 2, Working with the Power BI Service. Module 3, Connecting to Power BI Data Sources. Module 4, Creating Power BI Desktop Solutions. And Module 5, Power BI for the Developer. It is recommended that you watch the videos in the order in which the modules are presented. Module 1, Microsoft Power BI Overview. In this module, these 5 topics will be covered. A new generation of BI, introducing Microsoft Power BI, Power BI Overview, signing up for Power BI, and Power BI announcements. Today, BI extends to everyone. Business intelligence, or BI, has come a long way. And during the first 2 waves of business intelligence, IT professionals and business analysts were the guardians of BI. They made BI accessible and consumable for end users. While this approach still applies to complex BI needs, today there is a new wave. This third wave of BI makes BI available to every kind of user. Power BI has been designed to address 3 common BI challenges that organizations may face today. Getting an end-to-end view of what is happening. Because data is often in disparate locations, it can be difficult for business users to see a complete picture of the business. Managing multiple data sources. Data residing in software as a service solutions and other external locations can be difficult to manage programmatically or access and refresh securely. Making the data available to the right users at the right time. And also, mobile business users need the latest operational data at their fingertips, no matter where they are or what device they're using. Different roles have different needs and access levels, and so a one-size-fits-all solution doesn't necessarily work. Power BI has been designed as a cloud-based business analytics service that enables fast and easy access to data, whether from on-premises, whether from cloud. It presents a live 360-degree view across the business, supporting data discovery and exploration, insights from any device, collaboration across and within the organization, and anyone, providing them the ability to visualize and work with to analyze their data. Let's explore the key benefits and differentiators. Pre-built content packs consisting of dashboards and reports for popular software as a service solutions, including Google Analytics, including Bing, and a growing number of providers present quick-to-access content. Real-time dashboard updates. The ability to present data real-time, programmatically, or through streaming analytics is a compelling experience. Secure live connections to data sources, whether they're on-premises or cloud. So the ability to surface, for example, analysis services models from on-premises for live reporting and analytics through the cloud service. Intuitive data exploration by using the natural language query. By posing questions within a dashboard, responses are delivered through visualizations that may also be pinned back to the dashboard. Integration with familiar Microsoft products and commitment for scale and availability in Azure. And lastly, fast deployment, hybrid configuration, secure and integrated with existing IT systems. All of these benefits will be described within this series on Power BI. As an overview, on the left-hand side we see data sources, be them software as a service solutions, on-premises investments, for example with analysis services, organizational content packs supporting the ease of distribution of reports and dashboards within the organization, Azure services including Azure SQL Database and Stream Analytics, legacy solutions perhaps developed in Excel with the workbook data model, or newer solutions developed with Power BI Desktop. All of these potential data sources can work with the Power BI service. And once published or configured for access, they support the ability to visualize through reports, through dashboards, and to distribute through sharing and content packs. and the ability to ask natural language questions of the data and to pin results back for future analysis. I'll be presenting an entire module on Power BI Desktop in this course in Module 4, and you'll learn how this comprehensive tool can be used to prepare, explore, report, and then support the sharing of data solutions. In Module 5, I'll be introducing the Power BI REST API. This is a topic for developers, and it will explain to them how they can programmatically manipulate and push data to the service to deliver compelling and real-time dashboard experiences. No matter what industry or what role Power BI is relevant. For the business user, it could be as simple as accessing software as a service solutions. These content packs enable quick access to reports and dashboards. For the business analyst, working with a tool like Power BI Desktop, they can import, shape, cleanse, integrate, and model data, and then build compelling reports, and then publish these as solutions to produce dashboards and to share. They can also consider creating content packs to share insights within the organization. For the BI professional, perhaps working in the IT team, they can connect to live Azure data sources. They can connect to on-premises analysis services databases and empower colleagues to create their own reports. For the developer, there are programmatic scenarios including the integration of applications with Power BI, the creation and delivery of real-time dashboards, and the development of custom visuals to extend beyond the out-of-the-box visualizations available with Power BI. Users can easily and quickly get started with Power BI today. Sign up can be achieved for free and within seconds. Note that Power BI works only with an organizational account associated with a work or school email address. And would encourage you to encourage your customers to trial Power BI for free and to realize for 60 days the ability to work with the Power BI Pro features. In the summary of this training series, I'll be wrapping up by talking about licensing and reviewing the features that are supported only with the Power BI Pro license. And here are some interesting recent announcements. In February 2016, Gartner had positioned Microsoft as a leader for the 9th consecutive year in the Magic Quadrant for Business Intelligence and Analytics Platforms. For the first time, Microsoft is placed furthest in the vision within the Leaders Quadrant. And also, in March 2016, at the inaugural Microsoft Data Insight Summit, James Phillips, the corporate VP, announced a major milestone for Power BI, that the service has exceeded more than 5 million subscribers. The key takeaways in this module then. Power BI is a cloud-based business analytics service delivering end-user BI. Power BI delivers numerous benefits and differentiators, including pre-built content packs, real-time dashboard updates, live connections to on-premises and cloud data sources, intuitive data exploration by using natural language query, integration with familiar Microsoft products and services, and fast deployment, hybrid configuration, secure and integrated with your existing IT deployments. Lastly, Microsoft is placed furthest in vision within the BI and Analytics Platform Leaders Quadrant. To support your continued learning, you may find these relevant resources useful. Specifically, you'll find that Power BI is an evolving service, and so therefore we'd encourage you to subscribe to the Power BI blog. With the rapid change that takes place with Power BI, this is one of the best ways to keep pace with updates. We'd also recommend that the Microsoft Cloud and Enterprise Partner resources are an excellent location to find resources including customer-ready materials, customer evidence, training and labs, demos, and what to do next resources. Lastly, if you'd like to read more about Microsoft's positioning in the Gartner Quadrant, you'll find additional details and notifications at this link. In this short demonstration, I'll commence by signing into the Power BI service. And then let me point out that in my workspace, there are presently no datasets, reports, or dashboards. So I'm going to get data from a service, and we'll find that there is a content pack available for Bing. I simply click Get, and then I type in keywords. Let's take a look at the search term of Power BI. I click Add. Notice now in the left-hand side I have the Bing Power BI dashboard. Let's take a look at this dashboard in full screen mode. And we can see details like volume change from last week, and details about where counts of requests are coming from. So in a matter of seconds, there in less than a minute, I've signed in, connected to the Bing content pack, and produced a dashboard to show details about Power BI searches. Power BI has been designed to make it easy to get to data. Here I am clicking on Get Data, and we can see options to import content packs from software as a service services, internally published content packs from within the organization, the ability to upload files, be them Power BI desktop, CSV, or even Excel workbooks containing data models, and the ability to connect live to databases, be them cloud databases or even analysis services on premises. I've gone ahead and pre-produced a dashboard. In fact, a later demonstration will show how this dashboard will be laid out. But essentially, this dashboard makes it very simple for people to stay focused on key metrics and data. There's the ability also to ask questions. Show me sales by country. And there we see a visual in response. In CY, there we have the years, calendar year 2015. And now that I have that response, if I'd like to return to it, well, I'd probably likely pin that back to the dashboard, and then we'd see this would become a tile, as we see here. Dashboards are a great way of bringing together data from multiple reports and data sets, and there's also the easy ability for those dashboards to be shared. Up here in the top right column or corner, I can click Share, and then I could share this with other users within the organization and potentially also with those outside of the organization. Module 2, Working with the Power BI Service. In this module, these 8 topics will be covered: introducing the Power BI online service, creating and exploring reports, assembling dashboards, exploring with Q&A, mobile applications, sharing and collaboration, describing additional capabilities, and tenant settings. The Power BI Online Service offers a simple, intuitive experience for interacting with data. The service and features have been designed to simplify engaging with data from different data sources, fueling faster, more insightful business decisions, and to deliver richer, consolidated view of key information no matter where the underlying data is sourced. And lastly, the ability to share this with others internally within the organization and also potentially with those external to the organization. Users will engage with the service by either using a web browser or a mobile application. The supported web browsers include these 5: Microsoft Edge, Internet Explorer 10 or 11, Chrome Desktop, Safari, Firefox. Users typically work with the Power BI building blocks, and you'll notice here the preview of the navigation pane for a workspace. And you can see then that there are 3 groupings: the datasets, reports, and dashboards. The navigation pane supports the creation and the management of these building block assets. Microsoft encouraged providing feedback about the Power BI online service. You can do this by conveying the likelihood that you would recommend Power BI. You can explain why your score was given and add optional screenshots. And you can allow participation in helping Microsoft decide which Power BI features should be added next. Let's move to the topic of creating reports. We use reports to lay out visualizations across one or more report pages, and rich interactive reports can be created, updated, and explored in the web browser experience. Reports must be based on a single dataset, and we'll be exploring datasets in much more detail in the next module. Reports consist of one or more pages, and within each page they can be named and they can consist of visualizations and shapes. Dataset fields are used then to lay out a visualization, and you can see here on the right side we have the fields pane expressed in terms of tables, and tables have fields. These fields can be used to lay out the visualization and also to apply filters, and filters can be applied at report, page, or even individual visualization level. Sorting can also be applied at the visualization level. There are numerous modern visualization types. Filters, these are slices that support interactive filtering on the report page itself. For the display of numeric values, there are cards, multi-row cards, tables, matrices, and KPIs. For the graphical visualization of data, there are bar, column, line, combo, scatter, waterfall, pie, donut, funnel, tree map, gauge, and R-script types. And to spatially visualize data, there is the map and the field map. There's also the ability to import custom visuals, and I'll be covering custom visuals in Module 5 of this course. When you take a look at the visualizations pane, you'll see an abundance of visualizations, and as a tip, when you hover your cursor over them, a tooltip will reveal the description of the visualization type. For exploring reports, reports are available either in Reading View or Editing View, and in both views, report pages can be opened in full screen mode, or individual visualizations can be popped out or in to see them in a zoomed in or out mode. In the Reading View, users cannot change the report definition itself. They can, however, interact by changing filters or applying sorts. They can highlight values in one visualization to cross-filter to other visualizations on the page. Note that shared reports, they are reports shared to someone, may only ever be opened in Reading View. In Editing View, users can interact as in Reading View, but they can also save changes back to the service. Typically, the owner of the report has the ability to work in Editing View. And now on the topic of assembling dashboards. Dashboards display tiles on a single canvas, and a tile is sourced by pinning either a report visualization, or a response to a Q&A question. There are, in fact, other techniques for pinning dashboard tiles, and I'll explore these later in this module. A dashboard can be based on one or more data sets, so it differs from a report that has a one-to-one relationship to a data set. A dashboard can express data from multiple data sets through multiple tiles. These tiles may be resized and repositioned, and they may have their titles and subtitles updated, and they can be sized to 1 to 5 units wide or high. Tiles can be opened in focus mode, filling the dashboard space, and the data last updated date can be displayed. However, this won't be available for tiles sourced from Q&A questions. It's also possible to export the data from a tile to a CSV document on the desktop. Additionally, non-data related tiles can be added to a dashboard. This could be web content sourced from a URL, it could be an image also sourced from a web URL, it could be a text box with rich text formatting, or it could be a video. Dashboards enable interactivity, and by default, clicking on a tile will drill through to its source. However, it is possible to override this behavior by configuring a custom URL for that tile. Dashboard tiles can reflect live real-time data, and for non-real-time data sets, tile thumbnails are automatically cached every 15 minutes, or when data sets are refreshed. Dashboards can be displayed in full screen mode, and additionally, as described, all tiles can be displayed using fit to screen also. Let's take a look at the Q&A feature with natural language querying. The dashboard must contain at least one tile connected to a dataset, and only cloud-based cached datasets are supported for this feature. Q&A helps formulate an appropriate question, so it provides suggestions and autocomplete and even spelling corrections. You can also add featured questions to datasets so that they're prompted when people use Q&A. And note at this stage only English questions are supported. We would suggest you begin exploring Q&A by starting with show. Show me a table, show me some aggregate of a numeric column. For example, show me sum of sales. Show a measure by a column. Show a column where a column is before a date. Show a measure where the column is before a date value sorted by a measure. And much of the Q&A experience is really exploration and learning from this experience. Optionally, your Q&A responses can be customized, and then the responses can also be optionally pinned back to the dashboard. Let's see by example. If I type in show total net revenue in calendar year 2014 by month, the response may look something like this. Now, a close inspection of the months would show they're not in fact sorted chronologically, they are sorted in descending order of total net revenue. By modifying the question to say sorted by month, we now see chronologically sequenced months. I might then open up the visualization pane and request that the chart type is a line chart. Now, I could achieve this by applying settings from the visualizations pane, or I could also have modified the Q&A question to say as line chart. Satisfied that this returns the response and that I would like to refer to it in future, I have the ability to pin this back to the dashboard. Now on the topic of mobile applications. You can install native mobile applications to access dashboards, and these are available for Windows, iOS for iPhone and iPad, and for Android. Supported capabilities include setting favorites for important visualizations, zooming in and out of visualizations, annotating visualizations and sharing snapshots with others through email, and configuring alerts to receive notifications of critical business KPIs. In the mobile applications, dashboards can also be configured for phone view. So when creating a dashboard or editing the dashboard, you can switch the view to the phone layout, and you might take a dashboard like this and lay it out specifically for a phone view like this. And now to the topic of sharing and collaboration. Sharing and collaboration can be achieved by three distinctly different techniques. There is the sharing of dashboards and tiles. There's working with groups and organizational content packs. And note that the latter two techniques will require the Power BI Pro license. With the exception of on-premises analysis services datasets, be aware that all users will see the same shared data, so care should be taken not to share to those that ordinarily wouldn't have direct access to that data in the first place. The responsibility is on the sharer to ensure that they're sharing appropriately. So the first technique is to share dashboards and tiles. A dashboard can be shared to provide ad hoc access, or even individual tiles could be shared. Now, this is typically suitable for users that work closely together and that need to view dashboards or specific tiles. These users must have signed up for Power BI, and sharing with external users is possible if this capability has been enabled. Shared items in the navigation pane are identified through this sharing icon. And for the shared users, they're only read-only and they may not be customized. The dependent datasets are not made visible. The dashboard owner can allow other users to reshare. That would be internal users only. They can review share access and stop sharing with specific users. They can save dashboard changes, which will then become immediately available to all users sharing that dashboard. Dashboards can be shared from a user's workspace or also from a group. It's also possible in the navigation pane to filter the content by whether it's owned by you or whether it's shared with you. And now to the second technique, which is really a collaboration technique working with groups. This is typically suitable for teams and collaborators with whom you work closely for a common project. Now, every individual in Power BI has their own personal workspace. The creation of a group enables a group to own a workspace, and that group then can own assets like datasets, reports, and dashboards. Now, the group has a membership, and the membership consists of users, of which there must be at least one admin. And therefore, you can add other members into the group and then collaborate collectively on the assets for the group's workspace. Every member of the group must belong to the same tenant. They can have either read-only permission or complete permission, and if they have complete permission, they may update, create, and even delete any of the content for the group. But all users participating in a group must have a Power BI Pro license. The third technique is the organizational content pack. You use organizational content packs to make content available to broader internal audiences, and it also supports personalization of the content that is being published. This is typically suitable for anyone who might be interested in content. And a content pack is defined in terms of a title, description, even an image, and then specific assets that could be datasets, reports, or dashboards. Content packs are then made discoverable through the Get Data. They can be published to an entire organization if this has been enabled by an admin, or published to individual groups or individual users. By default, dashboards and reports will be read-only. However, it is possible that those that have subscribed to the content pack can unlock and personalize them. What does this mean then if you republish a content pack? Well, what it would mean is that those that have personalized or modified the content pack content will be provided a notification to say that changes have been republished, and they're presented with an option to adopt those changes. Here's a summary that compares the three techniques. Dashboard sharing. It's really ad hoc. The ability to share to individuals or colleagues inside or even external to the organization. It applies usually to dashboards, but it's also possible to apply to specific tiles, and this functionality is supported in the mobile apps. There is no such discovery. Upon sharing, automatically that content appears in the workspace. If it's a user that does not yet have signed up for Power BI, they will receive an invitation email, and having signed up for Power BI, they will see your shared dashboard. From a permission perspective, shared dashboards are read-only. The datasets are not visible, reports are in reading view, and resharing permissions, if granted, could enable them to reshare this to others. This is supported in Power BI and Power BI Pro. For groups, groups are about collaboration and typically suitable for small groups that need to work closely on a common project. It applies to all content owned inside the group workspace. Members of the group are either read-only or edit, and this is supported only with the Power BI Pro license. Lastly, the organizational content packs is about distribution to a broad audience. This could be an entire organization, or it could be to individuals or to members of groups. It applies to all content that you package up within the pack, and it is discovered through the Get Data and searching in My Organization. Primarily, the sharing is read-only. However, those that subscribe to the content pack may personalize and make updates. This feature is only supported with the Power BI Pro license. In this topic, describing additional capabilities, we'll explore a number of enhancements that have evolved with the Power BI service. So we learned that pinning could be achieved by pinning report visuals, also pinning Q&A responses. There are other techniques for pinning, including SQL Server Reporting Services reports. As a new capability delivered with SQL Server 2016 reporting services, visuals on paginated reports may be pinned back to your workspace dashboard. Pinning of Excel ranges is supported also when workbooks have been saved in OneDrive for Business. Ranges can contain data, charts, tables, pivot charts, and other Excel parts. You can view but not pin the tiles from workbooks that have been shared with you. There's also an add-in, the Power BI Publisher for Excel, that supports sharing snapshots of Excel elements to online dashboards. And so pivot tables, charts, and ranges could also be pinned and maintained through this add-in. Pinning real-time data. This is a new and preview feature at this stage. Real-time dashboard tiles can be created by pushing data to the Power BI REST APIs or from streams created in PubNub. You can create real-time streaming data sets, and there are code examples that are provided to you to facilitate creating the programmatic logic required to push to your individual dashboard tile. Here's an example, although it's not an animated example, but here's an example of a real-time dashboard tile. And if you can just imagine that it would update by the second delivering. Temperature statistics. This is a very interesting Internet of Things example. Quick Insights enables the generation of interesting interactive visualizations based on your data. This can be run on an entire data set or on specific dashboard tiles, and it can present up to 32 separate insights in a special Quick Insights canvas. This can allow you to further understand your data and to further explore with additional quick insights if necessary, and there's the ability to pin these quick insights back to your dashboard for future reference. With Analyze in Excel, users can view and interact with Power BI datasets directly in Excel. This enables Excel on the desktop to connect to a Power BI dataset and then to support pivot table analysis direct against the Power BI dataset. Note that this is supported for Excel 2010 Service Pack 1 or later, and it will require Excel updates to be downloaded and installed. Web publishing. This capability enables the easy publishing of your report to the web. And when you publish to web, this will provide public access, so you want to be very, very careful. This is unauthenticated access to a report, but it provides you an iframe that is simple to then embed into any HTML page. Data refreshes for the web publishing are automatically reflected in an embedded report, but it could take up to 1 hour for updates to flow through. Be aware that there are a number of limitations. For example, reports using real-time data sources or row-level security or analysis services that is hosted on premises are not supported for web publishing. Also, reports shared to you directly or through an organizational content pack may not be published. Reports in a group in which you're not an edit member may not be published, and R visuals are not currently supported for this capability. On the topic of row-level security, it's possible to restrict data access for a dataset for given users. Different users belong to different roles and can have different filter restrictions. As the owner of a dataset, it's possible that you can assign users to the roles, and you can also test reports by viewing them in different roles to ensure that the row-level security is doing what you expect. We'll talk more about row-level security in the Power BI desktop topic in Module 4, but at this stage we'll specify that there are some limitations. You can only define row-level security on datasets that were created by using Power BI desktop. Only imported data and direct query connections are supported. Q&A and Cortana, that I'll talk about in a moment, are not supported. Analyze in Excel is not supported, and external sharing is also not supported. If applied to a dataset owned by a group, roles will only be applied to the read-only members of that group. On the topic of data alerts, it's now possible to assign alerts on dashboard tiles. These are fully synchronized across platforms. Set and view data alerts in mobile apps and receive notifications through the Power BI service in your web browser. Alert notifications will be provided to you. Limitations, however, with alerts is that they're currently not supported for card tiles and date time measures. And alerts only work with numeric data types, and alerts only work on data that is refreshed. They do not work on static data sets. When you edit a tile, this is the alert icon. It will open up this pane that will support adding an alert and defining a condition, and also the notification frequency. You can also opt in to have an email sent to you when the alert condition is met. Cortana for Power BI, and Cortana of course is the personal digital assistant. It has a role to play in Power BI in that you can use it to look for answers in Power BI datasets by asking questions in a very similar fashion to Q&A. It does require that the dataset supports Q&A and is enabled for Cortana to access. And you can see here on the presentation there's a checkbox that you would check to allow Cortana to gain access to that dataset. The user will need Windows 10, at least version 15.11, which is the November 2015 update. And the user can add their Power BI account in Windows 10, and that would enable this capability to work. Note that Cortana for Power BI is currently only available in English. Answer pages are reports that are specifically designed to answer Cortana questions. On the report, you can enable Q&A, you can set the page size to Cortana, and if the page and page level filters you set require single selection, well, Cortana will then display the report as an answer if one and only one filter item is specified. You need to ensure that that dataset has been enabled for Cortana to access. Dashboard data classification. There's now the capability to classify dashboards to raise awareness of what level of security should be applied. The tenant administrators can build up a set of classifications, and we can see here a high business impact and a low business impact. The high business impact is the default, so all dashboards will be classified by the default. And then there's a shorthand, and then you can see the shorthand value for the classification on the right hand side appears next to the dashboard name. This is simply a tag, but it should inform users of the appropriacy, especially when it comes to sharing this type of dashboard. For administrators, there are a growing number of settings that can be managed, enabling you to turn on or off certain features. On this slide, I list all of the settings. So as an administrator, you may choose whether or not to enable publishing content packs to the entire organization, allowing the sharing of content with external users, whether publish to web is supported, whether export of data is supported, whether users can interact with and share our visuals, whether it's okay to allow users to ask questions about their data using Cortana, whether it's okay for them to use the Analyze in Excel, whether it's okay for them to use template organizational content packs. Also, the ability to create audit logs for internal auditing, and that last topic of data classification for dashboards, which by default is off. Key takeaways for this module. The Power BI online service offers a simple, intuitive experience for interacting with data. Users engage with the service by using a supported web browser or a mobile app. Dashboards display tiles in a single canvas, and a tile is sourced by pinning either a single report visualization or a Q&A response, or a number of the other techniques that were described with SQL Server reporting services in Excel. Sharing and collaboration can be achieved by 3 different and complementary techniques: sharing of dashboards and tiles, groups, and organizational content packs. Entire reports can be easily published to blogs and to a website. To support your continued learning, you may find these relevant resources useful. I commence this demonstration by creating a new dashboard. The topic and the title of this dashboard will be Reseller Sales for Calendar Year 2015. And to begin with, the dashboard is completely empty. Next, in the bottom left corner, I'm going to get some data, and specifically the data that I'll upload is from a Power BI desktop file, and I can upload this direct from my local file system. You will see in a later demonstration of this training series how this Power BI desktop file is created. Now, upon importing the file, it will add to my workspace both a dataset and a report. And we can see here now the addition of a dataset named reseller sales and also a report. We'll notice also in my dashboard that a tile has been added that enables me with a single click to drill through to the reports of that Power BI desktop file. Returning to the dashboard, I can ask a simple question like show sales by, and note the autocomplete here, by business type. And there we see the 3 different business types and the total sales. And I can further refine this by asking for a particular year, and let's select calendar year 2015. I could also further refine it by asking for a particular type of chart as donut chart. Well, if I spell it correctly. And there we see the response to my question. And because I want to return to this time and time again, in the top right corner I pin this as a visual back to the reseller sales dashboard. Then I exit the Q&A experience, and there I see the sales. Clicking on the tile for the report, we can also pin existing visuals from reports back to dashboards. So let me ensure the filter context is both 2015 for all countries, and then I'm going to go ahead and pin first the logo and then the 2 cards, and then also the combo chart. Switching back to the dashboard, I now see a layout consisting of those additional tiles, and now I'm going to resize and reposition. I'd like to see sales up top. I would like to see the sales per capita up top also, and then the 2 graphic visualizations beneath. Up here, we have the ability on the toolbar to enter full screen mode and then make fit. And so we can see there in a matter of minutes how I've assembled a dashboard based on getting data, based on asking a question and pinning the response back to the dashboard, and then from an existing report, pinning visuals back to the dashboard. Module 3. Connecting to Power BI data sources. In this module, these 3 topics will be covered: connecting to Power BI data sources, keeping data current in Power BI, and integration with Azure services. Connecting to data through Power BI is relatively straightforward and easy, and it can be achieved with a variety of data source formats. These could be content packs that were delivered within the organization, and as was covered in the previous module, this was a technique for sharing through the organizational content packs. And there are also content packs delivered through software as a service providers. Files can also be uploaded to the Power BI service. These could be Power BI desktop files or Excel workbooks. And databases and data services, be them cloud or on-premises, can be connected to from the Power BI service. Power BI enables connections to these software as a service applications, and connections require an existing subscription. Each content pack provides pre-built dashboards and reports, and literally minutes to wow, having connected, authenticated, your workspace will have reports and dashboards to commence analyzing and visualizing the data from these applications. For the files, these can be uploaded or connected to from OneDrive for Business, OneDrive Personal, or SharePoint Online. Note that updates to OneDrive files will automatically appear in dashboards and reports. The supported file types include Power BI desktop files, Excel workbooks, and CSV files, and there is a maximum size of 250 megabytes for an uploaded file. We'll be focusing on the Power BI desktop in the next module. In Excel 2016, there is direct support for publication of a workbook. Publication must be made to OneDrive for Business, and updates made from Excel 2016 will be reflected automatically in Power BI datasets. When a Power BI desktop file is uploaded to the Power BI service, it becomes a dataset. The report becomes a Power BI report, and then an empty dashboard is automatically created with a token tile to enable connecting to the dataset. If you upload an Excel workbook, the data model within the Excel workbook becomes a dataset, and any Power View sheets will become pages of a Power BI report. Note that pivot tables, pivot charts, and custom fields will not be recognized. For databases and data services, certain Azure services are available with Direct Connect. Queries are sent back to Azure as users explore and report on data, and dashboard tiles refresh approximately every 15 minutes. And these experiences are intended for users who are familiar with databases and entities that they connect to. Azure SQL Database, Azure SQL Data Warehouse, and Spark on Azure HD Insight are all supported, and only available though with the Power BI Pro license. Live connections to on-premises data can be made with SQL Server Analysis Services. There's support for SQL Server 2012 and later. And what's interesting is that the user's identity is passed through to the on-premises analysis services, enabling any roles and permissions to be enforced. Note that Q&A natural language querying is not supported with this live connection, and these connections can only be made by users with the Power BI Pro license. Power BI connects to data sources as the user, so connections will require valid accounts that meet the requirements of the data source, and depending on the application you're connecting to, there will be different methods and different requirements to authenticate. You will need to consult every individual service to understand the appropriate authentication method. On the topic of keeping data current in Power BI, the Power BI service enables online and on-premises data refresh for datasets that are uploaded from Power BI desktop files and Excel workbooks that have the data model. Data refresh can be either on demand or scheduled, and the minimum schedule frequency is hourly. This is achieved via a gateway, and there are two gateways. There is the Power BI Personal Gateway and the on-premises Data Gateway. Note that gateway access requires the Power BI Pro license. In order for Power BI to refresh a dataset, credentials must be provided for the data source. And credentials are securely stored so that Power BI can connect on behalf of the user. The supported online data sources include all Azure and online services for datasets created directly from services and from the Power BI desktop queries. For supported on-premises data sources for refresh, these include all data sources available in Power BI Desktop, and these will be covered in the next module. But two exceptions, the Hadoop file and the Microsoft Exchange connections, are not supported. Let's take a look then at the personal Power BI Gateway. A user can download and install the Power BI Gateway to refresh on-premises data sources. It's only available in 64-bit, and if it's installed with an administrator account, it will run as a service, otherwise it runs as an application. It's been designed to support secure data transfer by using SSL via Azure Service Bus. There is no requirement to open any special firewall ports, and note that there are certain scenarios that cannot be scheduled for data refresh. These would include any custom SQL statements in the Power BI desktop queries, Excel worksheet data, or Direct Connect or Direct Query data sources. The on-premises data gateway can be set up and installed by an IT professional, and it's designed to serve large groups of users and their requirements to refresh data in the Power BI service. The IT department can centrally manage the set of users who have access to the underlying data sources. They can gain visibility into gateway usage, such as the commonly accessed data sources and the users accessing them. The data sources include SQL Server Analysis Services in either multidimensional or tabular modes, SQL Server Relational Database, Oracle, Teradata, SAP HANA. Note that for analysis services, the Power BI user, as previously described, is passed to analysis services as an effective username. Integration with Azure services. Azure and Power BI have the built-in connectivity and integration to bring BI efforts to life. And integration can be achieved without necessarily the need to develop complex solutions. Already there is direct connect from Power BI to Azure SQL Database, Azure SQL Data Warehouse, and Spark on Azure HD Insight. These do not require any gateways, they just work, providing there are credentials to connect and authenticate with these services. Power BI Desktop can also connect to Azure services, and real-time dashboards can be achieved with Azure Stream Analytics. Here's the Get Data page for the Azure services, including Azure SQL Database, Azure SQL Data Warehouse, Azure Marketplace, HD Insight, Azure Blob Storage, Table Storage, HD Insight Spark, Azure Document DB, and Azure Data Lake Store. Real-time dashboards delivered with Azure Stream Analytics. You can use Azure Stream Analytics to push the outputs of streaming queries to Power BI dashboards. This enables the delivery of real-time data at scale. It can stream millions of events per second. It can perform aggregation across tumbling or hopping windows, and then they can be delivered real-time through dashboard tiles. There's also the ability to coalesce Azure services together to drive advanced analytics. And here a very high-level diagram describing how big data with Azure HD Insight combined with Azure Machine Learning for predictive analytics, orchestrated with Azure Data Factory, ultimately pushing data into an Azure SQL database that can then be used as a data set for reports and dashboards in Power BI. Key takeaways for this module. Connecting to data through Power BI is relatively easy. Power BI enables connections to software as a service applications. Files can be uploaded or connected on OneDrive for Business, OneDrive Personal, or SharePoint Online. Live connections to on-premises data can be made to SQL Server Analysis Services, multidimensional or tabular modes, SQL Server Relational Database, Oracle, Teradata, and SAP HANA. Power BI enables online and on-premises data refresh. And Azure and Power BI have the built-in connectivity and integration to easily bring BI efforts to life. To support your continued learning, you may find these relevant resources useful. And so here is the dashboard that I produced in the previous demonstration. Let's now take a closer look. I'm going to focus into one of the tiles here, and this shows us the sales by month for the calendar year of 2015. And I'd like you to notice that at the very end of the year, the last column represents November. In fact, we have no data for December. And as was the case when this Power BI desktop file was created, was that there was no December data. And so imported into the Power BI desktop file was data including up until November, and then that file was uploaded to the service. And so then the objective of this demonstration is to show how by installing the personal gateway for Power BI, I'm going to enable a data refresh of the data set in the cloud against an on-premises SQL Server database. I'm going to then download the data gateway. And I'll install it. So it will download and install. And then there's a decision that needs to be made. There are in fact two types of gateways. The on-premises data gateway is more for an enterprise workload, typically installed on a server, and it's going to support data refresh but also live connectivity to various data sources. In this demonstration, I will select the personal gateway, and this is designed to be installed on the desktop and to be maintained to support the data refresh of data sets within individual workspaces. So while this is installing, I'm going to switch across to SQL Server Management Studio, and here I'm going to run a query that is going to insert data for December. So now in the on-premises SQL Server database, there is data for December. And then in a second script, the script will do two things. It's going to create a login named Power BI, and then in the AdventureWorks data warehouse, it's going to create a user that maps to that login and grant that user permissions to read from various tables. And now with the gateway just about to install, we'll step through a series of steps to go ahead and accept terms and the install location, and then this is going to take a few moments to set up. We have success, so we'll then launch. And then sign in to Power BI. And there we have it. Success. The gateway is up and running. So now returning to the Power BI site, we're now ready to configure the data set for data refresh. And that's achieved by opening up settings and then selecting the data sets. And then we see here the reseller sales data set, and we should point out that the gateway here is up and running. Next, the Power BI desktop file in fact has two credentials. One for SQL Server and one because there is web data. I'm going to edit the credentials of both. So to connect to the SQL Server on premises, it's going to use that Power BI account that I created earlier with the script. And those credentials are now securely stored for use by the gateway. And then for the web, because it's a Wikipedia web page, we'll use the anonymous authentication. And now that all credentials have been provided, we now have support for data refresh by using this personal gateway. So let me switch back to the dashboard and let's bring this tile in focus. And now against the data set, either I could configure a scheduled refresh to take place perhaps once a day, or a maximum of 8 times a day with the Pro license, or an on-demand refresh as I will do now. Alright, so while preparing for refresh, and then take note in the navigation pane, you'll see a spinny as the refresh is in process, and then where I'm pointing with my mouse, we'll watch the data refresh take place as the December data will then appear in the dashboard tile. And there we have it, data refresh achieved with the personal gateway. Module 4, Creating Power BI Desktop Solutions. In this module, these 8 topics will be covered: introducing Power BI Desktop, creating queries, configuring relationships, enhancing the model, securing the model, designing reports, publishing to Power BI, and then describing additional capabilities. Power BI Desktop is a visual data exploration and reporting tool. It's freely downloadable in either 32 or 64-bit, and it integrates proven technologies that first found their way into Excel: Power Query, Power Pivot, and Power View. It enables multiple ways to transform schema and data, and it's updated at least every month. Feedback can be provided and is encouraged. You can send smiles, you can send frowns, and the product team are very good at responding to feedback, whether good or bad. Specific feedback can be sent directly by the rating experience. The user experience then. It all begins with getting data from somewhere, and sources can include file sources, database, Azure, online services, and other. And data can be simply and quickly loaded as is, or it may be loaded, transformed, and then queried via the data model. There are three views in the user experience: the report view, the data view, and relationships view. In report view, you work with pages of reports. In fact, I introduced reports in Module 2 with the Power BI service. The reports are almost identical in the sense that reports are one or more pages and they represent the visuals based on data. The intent of the application then is to land the user on the report canvas as quickly as possible, to retrieve data and then to start visualizing it and then potentially transforming the data, adding calculations. The versatility of report view and the immediate visualization of model transformations is a strong competitive advantage over many other data analysis and reporting products. In data view, we inspect, explore, and understand the data in the model. And this is a different experience from how you can view tables, columns, and data in the query editor. This is a view of the data after it has been loaded into the model. In relationships view, we get to see all tables, columns, measures, and any relationships between tables. The development methodology for more complex schemas may follow this methodology. At step 1, create queries, use the query editor to filter, cleanse, and prepare the data. At step 2, configure and refine relationships to establish the foundations of the model. And then enrich this model at step 3 with calculation logic. At step 4, design interactive reports with a broad range of modern data visuals. And then at step 5, publish the solution directly to the Power BI service. We'll take a look at that flow of methodology in this presentation, from creating queries, configuring relationships, to enhancing the model, designing reports, through to the publication to the Power BI online service. Let's start with creating queries. Queries can be edited before the data is loaded into the model, and once created, each query is referenced by a unique name, and it's defined in terms of a series of steps that use the language M. Most query step logic does not require writing formulas, as there are comprehensive functionality delivered through context menus and the ribbon. However, in more advanced scenarios, if you are familiar with M, you can write advanced logic and even expose functions. Queries can be sourced from different types of data: file, database, Azure, online services, and other. And we see here that the file sources supported include Excel, CSV, XML, text, JSON, folder for the file system, and also SharePoint folder. Database sources include SQL Server, Access, Analysis Services, Oracle, IBM, and many other popular database products. Azure services include Azure SQL Database and Azure SQL Data Warehouse and many other Azure services. And online services, this is a growing list of software as a service providers, and so we find that there are literally dozens, and these are growing week by week. Under the Other section, there are web sources: SharePoint List, OData Feeds, Hadoop File, Active Directory, Microsoft Exchange, ODBC, RScript, Spark, and a blank query for writing script logic with M. Direct query mode enables direct queries to be sent from the Power BI desktop file to the underlying data source, and this is in contrast to data being loaded, imported into the model. Not all data sources are supported for direct query. Those that are include SQL Server, Azure SQL Database, Azure SQL Data Warehouse, SAP HANA, Oracle Database, Teradata Database, and Amazon Redshift currently in preview. When the Power BI desktop file is published to the service, credentials will need to be supplied to allow connectivity to these direct query connections. If it's an on-premises data source, then the on-premises data gateway must be installed and the data sources must be registered to establish the data connection. The benefits of using this mode include the ability to build visualizations over very large data sets that would be impractical or impossible to import, and to ensure that reports are always delivering up-to-date data. There are some limitations when working in direct query mode. All tables must come from a single database. The query editor query cannot be overly complex. Ultimately, the query that you define must translate to the native query language of the data source, and not all query expressions can translate. DAX formula are restricted to a subset of DAX functions for a similar reason. Relationship filtering is limited to a single direction rather than both directions, although in preview there is a feature that allows you to trial this. The data type of the column cannot be changed. Q&A will not be supported in the Power BI service dashboards, and likewise quick insights will not be available. When defining your query, you use the query editor to filter, cleanse, reshape the data to the desired result. Steps can easily be produced by applying column filters and by using the commands available from the ribbon and the query and column context menus. It's a very flexible environment to work within. It's a what you see is what you get, and ultimately you'll build up a list of steps that produce the data set that you want loaded into the model. Numerous commands are available on the query editor ribbons and context menus. These allow you to manage columns, rename them, change data types, reduce rows by filtering or by identifying errors and removing those rows, transforming, splitting, adding columns based on M formulas. It's also possible to combine queries. This could involve merging two queries based on a common column or appending two queries as in a union. Having loaded queries into the model, at this stage they are then referred to as tables, and relationships will enable filter context to flow between tables. So it's important to point out that the relationships that you see in Relationship View are not foreign key constraints as may be interpreted from a relational database diagram. They are in fact pathways by which filter context from one table flows to another. For example, filtering on calendar year 2016 in a date table will pass that context through the relationship to ensure that only the rows for sales that have taken place in that calendar year would be aggregated. Relationships can be defined between any two tables regardless of the data connection or source type. However, they must be single column relationships with matching data types, and there's no support for self-referencing relationships to generate parent-child hierarchies. In the advanced options, it's possible to define multiple relationship paths between two tables. However, one must be active and all other paths must be inactive. And to use an inactive relationship would require an explicit reference in a model calculation. You can also configure cardinality, cross-filter direction, and the cardinality would allow you to support one-to-many or many-to-one, or now one-to-one relationships between tables. The cross-filter direction determines which direction the filter context flows. And by configuring it to both, you end up with some interesting arrangements whereby filtering the sales and filtering the date table can produce the desired results. Next, enhancing the model. Model tables can be extended with hierarchies, calculations, and these may also be hidden. The model column properties can be set with their data type property, how to format, categorization, especially for spatial types for mapping, whether the values in a column should sort based on another column values. For numeric columns, the default summarization, should it sum, should it average, min, max, and should it be visible. Hierarchies can be added to a table enabling navigation between columns in the one-to-many direction. And here we see an example of year, quarter, and month columns assembled into the calendar hierarchy. Adding calculations to the model can be achieved with three different techniques: calculated columns, calculated tables, and measures. All calculations are defined by using DAX, which stands for Data Analysis Expressions. This expression language has been based largely on Excel functions, although it has been extended to support modeling capabilities, and therefore it has table functions, aggregate functions, relationship navigation functions, context modification functions, and time intelligence functions. This is an involved topic, and so this training course will not go through the theory of DAX. We'll talk about the application of it though. And so calculated columns, defined by using DAX, simply adds new columns to tables. It's important to note that these increase the size of the model, and column values are recalculated when the table is refreshed or formula dependencies are refreshed. Calculated tables allow defining entire tables in the model based on a DAX expression that returns a table. And measures define aggregation logic in the model. And in contrast to calculated columns, the values for measures are not materialized or stored, they're computed and evaluated at query time. Common aggregate functions used by measures include sum, count, distinct count, average, minimum, and maximum. Tuning the model is important to improve the usefulness of Q&A. You can do this by setting appropriate column data types, formats, and categorization, ensuring that relationships are correctly configured, ensuring that tables and columns are visible or perhaps hidden if you don't want them to be candidates for use in Q&A. Also ensuring that tables, columns, and measure names are unique and concise. And it's also possible to define synonyms in Relationships view to provide alternate names that your users may refer to for tables, columns, and calculations. It is possible to secure the model by restricting data access to the dataset for given users. Filters can be used to restrict data at row level and are assigned to roles that you define within the Power BI desktop file. Once published, it is possible then to assign users to these roles. Limitations with row-level security include only imported data and direct query connections are supported. Q&A on Cortana are not supported. The Analyze in Excel feature is not supported, and the external sharing of reports based on these datasets are not supported. Row-level security is a Power BI Pro feature. And now to designing reports. Reports can be designed based on the visible model interface, and the design experience is almost identical to that available in the Power BI online service. Text boxes, images, and shapes can be added, and text boxes can contain hyperlinks. Custom visuals can be imported to extend beyond the out-of-the-box visualizations, and we'll talk about custom visuals in the next module. And now that the Power BI desktop file is complete, queries have been loaded, appropriate relationships are defined, enhancements are made to the model with formatting, naming, calculations, reports have been designed on top of the model, and now as a single file, it can be published direct to the Power BI service. You can publish direct by using a ribbon command, or you may upload the file from the Get Data in the Power BI service. Do note that if you're overriding an existing dataset, if there are two or more datasets with the same name, you should remove one or rename one. Otherwise, it will overwrite. Renaming columns or measures can break existing reports or dashboard tiles. So if you are uploading a new version of the Power BI desktop file, please be sure that it's compatible with existing reports and dashboards that have been created, maybe not just by you, but perhaps by other users. If row-level security roles have been defined, once published, you will need to assign users to those roles. Let's then describe some additional capabilities, including query parameters, Power BI template files, running R scripts, generating R visuals, and shape maps, a new feature presently in preview. Query parameters allow users to easily make parts of their reports and data models depend on one or more parameter values. These parameters are defined in terms of a name, a description, data type, allowed values, a default, and current value. And then these parameters can be referenced from queries and loaded to the data model. Many dialog windows support referencing parameters, including data source dialogues, filter row dialogues, and replace value dialogues. Power BI template files allow users to export the definition of the Power BI desktop report without including the actual data. Users can then easily instantiate a template and then, passing in parameter values, generate their own Power BI desktop file. R scripts can be run directly in Power BI desktop and the resulting datasets imported into the data model. This will involve that R is installed on the local machine. Only data frames can be imported, and columns typed as complex or vector are not imported. These can be refreshed with the gateway. And then R visuals render from R script accepting input fields. And the benefits are that you can leverage the voluminous and growing number of out-of-the-box plots available in R, easily customize R visuals by developing the script, combine advanced analytics in visuals, and interact with R visuals in Power BI desktop. And then finally the shape map, which is presently in preview. In contrast to the map visual that we already have, the shape map cannot show precise geographic locations of data points on a map, but instead what it shows is relative comparisons of regions on a map by coloring them differently. There are maps out of the box, but custom maps can be used providing they're in the topo.json format. And so possibilities include displaying geographical maps, seating arrangements in theaters, floor plans in supermarkets, and so on. Key takeaways for this module. Power BI Desktop is the companion desktop application to Power BI. It is a visual data exploration and reporting tool, and this tool enables simple and quick visualization or support for more complex schemas, and development methodology can include creating queries, configuring relationships, enhancing the model with calculations and hierarchies, designing reports, using custom visuals, and then publishing to Power BI. The user can choose to work in the way that makes most sense to them and their requirements. Power BI desktop files, once published, can have their data sources refreshed. To support your continued learning, you may find these relevant resources useful. Take note of the DAX Resource Center. We didn't include any coverage on DAX, but this is an excellent location to reference a number of quality resources available on DAX. I commenced developing the simple Power BI desktop solution by launching Power BI Desktop. This is a free download from Microsoft in 32 or 64-bit, and it enables the development of modeling and reporting. And the output of a Power BI desktop file will be a file that can then be imported or uploaded to the Power BI service. In this very simple example, I'm going to connect to SQL Server, enter the server details and the database name. We do have an option here to either import or perform direct query. I'm going to use the default of import that will retrieve and then efficiently compress and store the data within the Power BI desktop file. An alternate is to use the approach of direct query, and direct query would only store the definition of how to retrieve the data, and then any queries at report time would actually be sent direct down to the underlying data source. Once deployed to the service, however, this would require the on-premises data gateway to support that behavior. Moving forward then with the import approach, we then need to authenticate, and I'll use my Windows credentials. And then it presents to me a list of views and tables in the database. In this very simple demonstration, I'm going to source the data from one table, and that is the fact reseller sales. Now I do have the potential to edit and transform this data, but in this simple example, I'm going to load the entire table. Presented in the right pane then is the fields list, exposing the table and all columns. We'll note that columns expressed with a sigma symbol are numeric and therefore may be aggregated or summarized within a report. In this simple example, I'm going to take the sales amount column, and we'll note by default it's expressed by using a column chart, and it's aggregated to give me a total of some $77 million worth of sales. I'm going to go ahead and just drag in the order date field, and what that presents to me instantly is this chart showing me the sales by year. I'm going to then enable drill down, and once enabling this I can drill down within 2015. There's also the ability for me to drill to the entire next level. So from the 4 quarters of 2015, here we see all of the months for 2015. And that concludes this simple Power BI desktop solution. In the next demonstration, I'm going to remove this visual and customize and extend the model to show a more advanced application of using Power BI desktop. To enhance the Power BI desktop file, the first thing I'll do is remove the existing visualization. Next, I'm going to edit queries, and let me maximize the query editor. In the previous demonstration, I loaded an entire table, all columns, all rows. That's not terribly efficient. What I will now do is narrow these down to particular columns. Just the 3 at this stage. I will bring in sales amount. I'll bring in also order date and also the DIM reseller. With those 3 columns multi-selected, I can right-click and remove other columns. And we'll note then that DIM reseller doesn't present a value, it presents a link to values, and this is in fact because it represents a foreign key relationship from fact reseller sales to the DIM reseller sales table. That provides very ease of access to the columns in the related table. Specifically, I would like to bring in business type and also DIM geography, which in fact is another relationship from DIM reseller to the DIM geography table. Let me likewise expand DIM geography to retrieve only the English country region name. And now I have a single query result that in fact joins 3 tables and delivers 4 columns. Next, I will rename each of these columns to something that is far more simple, and this ensures that our reports look good, but also with the feature of Q&A. We want to think in terms of friendly labels that are likely to be used while asking questions in Power BI dashboards. Right, so now I have the 4 columns. What I will do is close and apply. And we'll note then in the field list we have a far more simplistic expression of factory seller sales. I could also apply renames at this level also, and I'll choose to rename the entire table to something more friendly like reseller sales. And in fact, the page 1 down in the bottom left corner here, I will double click, and I will also name that this page of the report will be named reseller sales. To commence the layout of the report, I'm going to introduce an image, and this will be the AdventureWorks logo. I can also add in a text box and apply text formatting, and then reposition this across the top. Okay, now with the commencement of the report, let's now take a look at the model. So I'm switching now across to the data view, and in the data view we get to see that we do have an order date column, but typically the analysis and reporting that we'll do would be at different granularities like year or month. And so I'm going to use a capability available here on the modeling ribbon to introduce a new table. And the table will be named date, and I'll use the DAX function of calendar auto And what Calendar Auto will do is create a new table consisting of a single column, and we see that column here named date. And according to the dates that it found in the order date column of the reseller sales table, this column here, it's gone and generated a sequence of dates for the entire calendar years to ensure that the dates are available in the corresponding column. So I can now extend this with other types of calculations, in this case a new column. For this new column, I'm going to use a DAX function here. The column will be named year, and it will use the text of CY and concatenate that to the year value. Let me copy and paste this in. And there we see an addition of a column that allows grouping by year. Let me add a second column, and this time this will be the month column, which will take the value of the year column and then concatenate a space and the month in abbreviated format. And now I have a table of date consisting of one row per date and 3 columns. Let me now switch across to the relationship view. We'll indeed see that the reseller sales was sourced from a query coming from SQL Server, and the table is a calculation. And I can then drag and drop to establish a relationship between these two, providing they are single column and matching data types. And then I'll choose also to hide these columns so they're not available in reporting view. Now when I switch back to report, then you'll see that I have my date table here on the right. Let me drag and drop year into the report surface, and I'm going to configure this as a slicer, and this is going to support interactive filtering, and I'll initially filter by calendar year 2013. Next, I'll drag sales, and then I'm going to create a card. And so I see that the sales, and this is a little hard to read, so what I might do here is just come to the styling, and we'll specify that this should display in terms of thousands with 0 decimal places. And I might also go ahead and apply a background color. Let's make this a background color of blue. And then as I filter on different years, right through to 2015, we get to see the sum of sales. I'll drag sales to a blank area to produce a new visual, and I will also drag in month. So now for the filtered calendar year 2013, I see all of the months. And something should stand out as a little strange here, is that we have this descending sequence. And the fact is that by default, the visual is sorting the months by descending order of sales. Well, in the top right corner, when I click the ellipsis, I can request to sort by month. And now we see the sorting by month. But you'll note that the order is still not quite right. In fact, September, October, November, May is descending order based on text. So let's at least switch it again by selecting sort by month to bring that to ascending order. But clearly it's sorting by the text value of month, not the chronological sequence of month. And that would then prompt me to do something like this. I'm going to right-click the date table and add a new column. And that new column will be a month key. And in fact, what it takes is the year value multiplied by 100 plus the month number. And this gives a numeric value that could be used to sort the month values. So now we have the addition of a new column. I now select the month column, and under modeling, I ask it to sort by month key. And now we can see the result is that we have January, February, March, April, May. The last step would be that I would hide the month key, that its purpose is to sort the month column. We would never report on this value directly. Now, the next step in this development is to integrate some additional data. And the business requirement here is not just to report on sales by month, but also to look at sales by country and to do some per capita analysis. So switching to Internet Explorer, I have a favorite, And this favorite is the Wikipedia list of countries by population in 2010. And I've decided from my research that this is a good enough quality set of data, and I would like to load this in as a table and then integrate it with the model and add a calculation to enable sales per capita analysis. So I'm going to take and copy that URL, return to Power BI Desktop, and then here on the Home ribbon, I'm going to bring in data, this time from the web. I'll paste in the URL, and then we'll use anonymous authentication. And then I know that it's the very first table, which has been retrieved as table 0. And we can see here in preview that that's very much the set of data we want. Instead of loading it, I will edit, and that will add the query to my queries, and then I'm going to provide a more friendly name, which will be country, and then I'm going to transform this data into the desired state to support the modeling and reporting requirements that I have. Now the first column provides rank, and rank is not of interest to us in this solution. We'll note also that column 1 contains supplementary data that is more header related, and row number 2 is really a grand total. And I've spotted an easy way to remove these, and that is if I select the rank column, noting that these values here are not numeric, what I will do is change the data type to whole number, and both of these then deliver errors. Then I can right-click the column header and I can remove any rows that have errors. And next I remove the entire column. And then I'm going to rename the columns to keep them friendly. This will become country, and this one will become population. And then lastly, the population, we can see here by default it's a text value because it was retrieved from an HTML page, and I will switch this across to becoming a whole number. And so now I've retrieved a table of data from the web, and I've sufficiently transformed, cleansed, and formatted it, and now I can close and apply. And here it is. We can see country is now available inside the model. Let's take a look in relationship view, because what hasn't happened is the establishment of a relationship between country. And then I'm going to hide country in this view here. Switching back to report view then, I'm going to add country as a slicer. Now you'll see by default it recognizes that it could be visualized as a map, but I'm going to switch that across to a slicer. And we see the two countries of Canada and United States. Now, the reason that we're seeing just the two is that with a filter context for year 2013, they were the two countries that we sold to. In 2014, we see the list grow to include France and Canada, and then in 2015, increasing to Germany and the United Kingdom. Let me configure the slicer then, so that under selection control, we have a select all, and we'll turn select all on for now. The last stage of the enhancement in this demonstration will be to add a measure, and this measure will enable us to report on sales per capita. And this is the whole reason that we brought the population in. From my snippets, I have the DAX required for this. The measure name will be sales per capita. It will use the DAX function that will divide as the numerator the sum of sales divided by the sum of country population. So I right-click the reseller sales, I add a new measure, and then I paste in that snippet. Next, I will format this to 3 decimal places. And now I can drag sales per capita, and I can make a new card for it. And we'll set the background to a color like purple. So we can see overall for the sales achieved in 2013, For Canada and United States, it was 0.47 cents per population. In United States, it was 0.43, and in Canada, it was 0.47. Lastly, I'll take that column chart and I'll convert it to become a line and stacked column chart. And then I can drag sales per capita into the line values. And that very much completes a more sophisticated Power BI desktop file that enhanced the existing simplified solution by refining the query for SQL Server, importing a second query based off a web source, and then enriching the model through relationships and calculations, and then expressing them in this dynamic report. Module 5, Power BI for the Developer. In this module, these 4 topics will be covered: extending Power BI, the Power BI REST API, custom visuals, and Azure Power BI Embedded. There are exciting opportunities for developers to extend, embed, and customize the Power BI experience. With the Power BI REST API, it's possible to push data directly from an application into a Power BI dataset. This can be achieved from either a client or a web application. The developer can then programmatically manage resources, including datasets and tables. And dashboards will update in real time as data is added. Let's take a look at the object model hierarchy. A Power BI workspace can have multiple datasets, and each is identified by a unique GUID. A dataset can be owned by a user or a group, and it may contain multiple tables, which are referenced then by name, and then each table consists of rows. An application must be registered and is required to establish an identity for your developed application. Applications are identified by their client ID, and you can delegate permissions to the Power BI service. REST API calls are then made on behalf of an authenticated user by passing a token for authorization in the header of each request. The application can be registered with the Power BI app registration tool or with the Azure Management Portal. And the Power BI app registration tool is the easiest option, since there are just a few fields to fill in. The authentication flow for the client application flows like this. In this presentation, I'm not going to go through the detail of this process. And for the web application, it's somewhat different. The operations currently supported for the Power BI REST API include listing all datasets within a workspace, creating a dataset, listing tables for a dataset, updating an existing table schema, adding rows to a table in a dataset, clearing all rows from a table, listing groups, listing dashboards, listing dashboard tiles, and listing reports. Note that the last 3 are still in preview. Let's take a look at an example of how to list datasets within a workspace. Programmatically, you would create a request, a GET request of this URL, and you would add the token. In response, this JSON document would describe all datasets in terms of their unique ID and name. Let's take a look at another example, this time adding a row to a table in a dataset. Programmatically, the request would post to this URL, and note that the URL includes the datasets and the GUID for the dataset, and then the tables collection, and then the name of the table and its rows. It would include the token, and then the JSON document that is posted would be a collection of rows, defining columns and values. There are restrictions. The maximum rows per single push is 10,000, and note that ingestion rates are also restricted by license. In the Power BI license, there's support for 10,000 rows per hour, with the Power BI Pro license, 1 million rows per hour. The maximum rows per table is 5 million, although a dataset is defined with a retention policy, and so none would mean that the rows would collect to the limit, but by specifying a basic FIFO, it would keep up to 200,000 rows, removing the oldest as new rows are added. The maximum number of pending requests is 5. Integrating a Power BI tile or report into an app can be achieved with an iframe HTML element. Use the REST API to retrieve the embed URL, and then once embedded, a click event handler can be added to enable navigation to the dashboard. This capability is still in preview. Developers can develop custom visuals for use in Power BI. And to help developers get started, Microsoft has published the code for all of their visualizations, and this is available on an open source project on GitHub. There are some 20 visualization types, the framework to run them, and the testing infrastructure that enables you to build your own high-quality visualizations. Developers are very much encouraged to submit their custom visuals to the Power BI Visuals Gallery and sharing of these to the Power BI community. Lastly, the Azure Power BI Embedded Service. As an Azure service, it enables the integration of Power BI reports into your applications. You can create compelling interactive reports by using Power BI Desktop. These reports can be embedded into your applications, and they can be deployed quickly and managed with ease. Key attributes of this new service. You easily author interactive reports without writing any code by using Power BI Desktop. You can choose from many modern visualizations that are out of the box or customize without building them from scratch for your reports. You can easily embed interactive visuals into your app by using the REST APIs and the Power BI SDK. You can ensure consistent, high-fidelity data experiences on any device. You can use your existing authentication and authorization methods, speed up time to value without redesigning your existing app, and pay only for what you use with no upfront costs. As a developer, you would then, with your Azure subscription, create an Azure Power BI Workspace collection. This workspace collection can have as many workspaces as you like, but within each workspace you may publish Power BI desktop files, and then you may embed these into your apps. They're designed to use direct query with Azure sources. These could be Azure SQL Database, Azure SQL Data Warehouse, or Azure HD Insight with Spark. From a pricing perspective, it's free for the first 100 sessions per month, and then $5 per session. And the definition of a session is that it ends when either the user closes the report or 1 hour after the session was initiated, whichever comes first. Key takeaways for this module. The Power BI REST API can push data directly from an application into a Power BI dataset. This delivers real-time experiences in dashboards. Developers can integrate Power BI tiles and reports into applications. Developers can develop custom visuals for use in Power BI solutions. And developers can embed compelling interactive reports within their web apps. To support your continued learning, you may find these relevant resources useful. In this demonstration, I'll deliver a real-time Power BI dashboard by using the Power BI REST API. In previous demonstrations, I produced this dashboard, and at the end of this demonstration, I'll be adding in a new tile. In fact, 2 new tiles that will express real-time data. Let me commence by opening up a new web session, and I'm going to need to use the Power BI app registration tool to register an application. First of all, I sign in by using my existing account, and then I provide an app name, demo. Is it either a server-side web app or, as is the case in this demo, it's a native app? I need a redirect URL, of which I will copy it from my snippets file. And then the application needs to be delegated permissions at step 3. And I will grant all permissions that is to read data sets, read and write to data sets. While I won't demonstrate this, it's also possible to read dashboards and read report details and to read groups that the authenticated user belongs to. At step 4 then, I register the app. And this client ID will then be required when authenticating with the service to retrieve a token, and that token will then be used for all REST API calls. Let me copy this to the clipboard. Here I have a Visual Studio project. It's a C# Windows application, and I'm going to go ahead and start. In the options, I'm going to paste in the client ID that I just registered, and you'll note that the redirect URI is also included here. The other URIs are fixed and are required to connect to the endpoints of the Power BI service. Next, I will connect, and this will require authenticating with the Power BI service. And then I accept that this application has these privileges. And what takes place programmatically is upon authentication, a token is retrieved and it's cached within the application. Let's then explore the user workspace consisting of datasets and dashboards. When I right-click and I get datasets, there's an API method that allows me to enumerate datasets, and we see that there's the one dataset of reseller sales. In fact, that is the dataset that we see right down here. What I will do is right-click the datasets folder, and I'm going to create a new dataset programmatically. I'm going to drive this from an event source. This is just an approach that I've developed here that will read a single result set being returned from SQL Server, and it produces this JSON document. Let me describe. The JSON document describes the name of the dataset. I'm going to call it e-commerce. It describes a collection of tables of which there needs to be at least one, and here we see one that is named weblog. And it has the columns described in terms of names and data types. The retention policy could be none or basic FIFO. None supports up to 5 million rows being stored, whereas basic FIFO will store up to 200,000, and then by the time the 200,001st record is inserted, the very first record is dropped off, and it will therefore maintain 200,000 rows moving forward. Now, watch when I click OK. Watch over here live within the Power BI service, we see the e-commerce web's dataset has been created. I'm then going to use the API method to get the tables when we find out that there's one table named weblog. Alright, so I'm now going to switch back to the Power BI web, and I'm going to click on e-commerce, and the default behavior when you click on a dataset is that it creates a new report, and we see here the weblog table in the fields list and our fields. Alright, what I will do is just drag, and it doesn't matter what I drag, I'll drag out product. Because there are no rows of data yet in this dataset, what I'm doing is producing a card here. It says count of product. What I will do is save this report as weblog, and once saved, I can then pin to my dashboards. So now when I switch to the reseller sales 2015, we see a tile here named count of product. I would prefer to rename that to represent really the number of requests, and currently with blank. Alright, well, when I right-click the table here, I can push data, and a single JSON document is all that's required, and then from my snippets I have that JSON document that is going to insert a single row. And so you can see here a rows collection and then a mapping between columns and values. So let me copy and then paste that into this window. And then watch when I click OK that the dashboard tile will update instantly to show that there has been a single request. Alright, let's do this now by pushing lots of JSON documents and representing an event stream. I'm going to cache all of the rows of data coming from that SQL Server stored procedure, and I'm going to push 10 events continuously into the service. And we'll see this now. There's 11, 21, and so on. So all that's taking place here with the REST API is it's just pushing a JSON document with the rows details up to the service. And now I could return with a question that says, show number of product by country name. And I'll pin that, return to the dashboard, and let's take a look at this in full screen mode. We see real-time data being updated here by the second, and all achieved by using the Power BI REST API. Summary. In this summary, we'll return to the Power BI overview and also the Power BI benefits by role. We'll talk about the Power BI licensing and point out differences in features and capabilities, and then signing up for Power BI. Recall in the first module, as an overview of Power BI, we saw that any source of data, whether it's software as a service applications, on-premises data models, organizational content packs used to distribute content within the organization, Azure services, Excel files, and Power BI desktop files could all be potential data sources used by the Power BI service. We saw that dashboards could be created based on datasets and reports, and natural language querying could be used to ask questions and to deliver responses that could be pinned back to dashboards. We explored 3 different techniques for sharing and collaboration, and described that the Power BI dashboards and reports can be delivered through web browsers and also mobile applications. The Power BI desktop is the companion application that provides the ability for you to develop complex schemas consisting of multiple sources, business logic, reports, and that can be published up to the Power BI service. And then in the last module, we explored for the developer how the Power BI REST API could be used to create datasets and to push data up to those datasets to generate real-time responses in dashboards. In review, the Power BI benefits by role. Whatever the role, Power BI brings data together, and this could be of interest to business users, business analysts, BI professionals, and software developers. 2 licenses are available. Great news, Power BI is free. To leverage the advanced capabilities and features, your users will require the Power BI Pro license, currently at US $9.99 per month with an annual subscription. We would encourage you to encourage your customers to review the pricing and feature matrix. Please note that the Power BI Pro is available as a trial license and can be obtained for up to 60 days. Let's take a look at feature differences. Data capacity is 1 GB for the free license and 10 GB for the Power BI Pro. To consume content that is scheduled to refresh, the Power BI users can only consume content that refreshes once per day, but Power BI Pro users may consume content that can refresh up to 8 times per day. For data streaming, and this is relevant for developers pushing with the REST API, for the free license, you can push up to 10,000 rows per hour, whereas in the Power BI Pro license, you may push up to 1 million rows per hour. For live data sources with full interactivity, there is no support for the Power BI free license. For access to on-premises data with gateways, also no access for the Power BI free license. For sharing dashboards, this is possible for both licenses, but all other collaboration features, including groups and organizational content packs, are only supported for the Power BI Pro license. Lastly, for securing Power BI desktop datasets, row-level security is only supported for the Power BI Pro users. Note that non-Power BI Pro users can share dashboards. However, a Power BI Pro license is required to interact with or consume any content that uses features that are only available to users with a Power BI Pro license. To support your continued learning, you may find these relevant resources useful. We encourage you to explore the virtual labs. There are a growing library of Power BI technical labs available at this URL. These labs are delivered with their own virtual machine, resources, and documentation. I hope this inspires you and your customers to get started with Power BI today.